Okay, what I have here is something that I just made with some engineering drafting, I guess, tools. So what I did is I made a circle, obviously, and I drew up the two types of navigational radar for land and air. Well, if you see here in the top, this is a land sonar radar. So the way this works is, obviously most people know this, but sound or radio waves are dispersed outwards, and as they go along the surface, they hit physical objects and bounce back, and it generates an image. And this bottom one, which is upside down, I'll make the orientation, I guess, kind of right for you. So, what's going on here is this bottom one is a flight orientation radar. This is generally how you have your radar set up in a cockpit. Not exactly, but generally. So, the way it works is you have, just like a drawing, you're supposed to have 3 points of perspective, okay, and a horizon. Now, what I find interesting about the plane radar is that, unlike the ground, it has a flat line, which I think is odd because, according to the heliocentric model, the Earth is round. So, according to that, there would be no flat ground at the altitudes that planes fly at. So what they would be seeing, okay, at their altitude, bear with me for 1 second, is something about like this, right about here. They would be seeing something of a curvature. I'm holding this as close as I can, but you see, no matter where you look on a flat globe or how close you are, you cannot see a flat horizon. It just is impossible. So, being that it is, why are the lines straight when not curved? Because if the Earth was curved, they would use a radar system similar to how the land sonar radar works, which is, if you look, round, which would travel around and show you, that would be your horizon, those curves. These curves right here would be your horizon. So this would be able to help you on a globe, on a heliocentric model, navigating it to ensure you are staying within the proper, I guess you should say, zoning of the sky, so you don't go into space. I'm not really good with terms, but just please, I promise you, this ain't stupid. But now back to the land radar. What's interesting is 3 points of perspective. Okay. So you got your 3 points of perspective, same thing, whether you're in land or air, you still need a 3-point perspective to get where you are at, of the location where you are, of the point of view. But why do they use rings that go outwards? Okay, radar technically wouldn't work on a globe because your sound waves would not travel along a curve. Sound doesn't curve unless it is forced to, or magnetized to, or influenced in some other way. So why is it that in the air you have flat to show you horizon, but on the ground it's dispersing out in a disc shape? Very, very, very odd, isn't it? Well, it's because if you look at it, it's a disc, people. It's a disc. Alright? So, if you take a disc and you start at the edge, alright, as you raise up, look what happens. Your horizon raises with you. Your horizon keeps going until there's nothing left. I'm sorry this isn't a big enough surface, but why? How can you find this right here on this? Because you can't. There is no flat. But guess what you can find it on? A disc. Perfectly flat horizon, as you can see. And if you look at this, it would perfectly disperse across a disc, radar. So if you think about it, these instruments that we are using are set up in a way to blind us and fool us, to make us think that we are on a globe.